Excellent. So thanks, folks. I'm really excited today. I think first and foremost, I want to talk a little bit about Calyptic Core, right? Transformation and processing is always an interesting word to use because sometimes we think of doing processing as coming out with some sort of outcome. Are we reducing? Are we removing? Are we adding? But there's a lot of different ways that we can use this word processing to get the outcomes that we need. We'll talk a little bit about why Calyptic Core in the first place, why is something like this useful in the context of observability and security. We'll talk about processing use cases, how folks are leveraging that today, go through some architecture. And then, of course, we're going to go step by step, very hands-on, and again, try to show how this stuff works live. So that way, if you want to try it out yourself in the playground, or you want to deploy Calyptic Core, you get a great way and a great way to go about doing that. So first, let me talk a little bit about the world we live in, or at least the world that we have seen as we've been contributors and creators of open source. There is a lot of complexity out there, right? We are just seeing an eruption of tools, awesome tools, by the way, like things that are fantastic for specific streams of data, whether that's in security context, whether that's in observability context, and more agents that can help connect from A to B. We're finding a lot of data layering tools, things like how do we do data in motion? How do we do data lakes? How do we do data warehousing? And a lot of custom built applications that surround that. Now, what we're also finding as part of this amazing eruption of innovation, both on the sources and destination side, is the complexity that comes alongside that to be very difficult to maintain, hard to scale. And sometimes when you have data that applies to multiple business use cases, it's really hard to prioritize one versus the other. And so what we have been building as part of Calyptic Core is this idea that you get full control of your data from that source all the way to the destination. So how you might want to do that processing, how can we help you better collect that data? How can we help you better route that data from one to multiple different inputs? Applications, this has been a fun one as we've seen. It doesn't just encompass the Java apps and the Python apps of the perhaps the past. It also encompasses things like SaaS audit logs. You might have audit events that are being generated from your SaaS services. Salesforce has a whole audit trail. You've got HubSpot, you've got Okta, you've got maybe Darktrace, CyberArk. There's just an enormous amount of SaaS applications that are becoming really pivotal to a business operation. And you need to make sure that you don't have any blind spots, say from a security context or a blind spot from an operational view. Now, from an infrastructure and cloud platform, these are also places too where infrastructure today might just mean servers, but is evolving to things like Kubernetes and microservices, even client machines, laptops, and how do we make sure that the collection from those clients and laptops is fully taken care of? And then last but not least, the cloud platforms. I think many organizations have fairly developed cloud strategies or are building a very cohesive private cloud strategy. And each of those platforms, doesn't matter if it's OpenStack on the private side to AWS or Google or Azure on the public side, they have their own interesting ways to go and retrieve that data. And this is where we've really focused on building the processing. Now, I want to take a kind of amalgam of a couple, what we've seen in the world of actually implementing this out. And I sure showed that in the past, but this is a fun one. Actually, two of our customers had very similar architectures. One within a telecom sphere, and the other within more cybersecurity side. And you've got all of these really proprietary connectors that help you connect to a particular backend. You've got some legacy stuff around. You've got, of course, our syslog that's connected to a bunch of devices, perhaps firewalls. And if we think about this, there's about 4 to 5 different applications that we have to go manage. We have to manage a Java-based application. We have to go manage connector-based applications. We've got to manage Windows-based applications, and then we have to manage these large syslog outputs. Now, from a processing side and a routing side, this is also where we're finding with users, they're able to really take this idea of how do I control that entire collection all the way to the end, bring a lot of processing power within the pipeline itself, and then route it to the particular backend, or at least simplifying that tech stack, if you will. So having the capability to deploy, manage, operate, do the transformations, and of course, that's what we're going to run through a lot today. Is how do those transformations actually look? Like where are those taking place? And this is a bit of a more architecture view, but I think it's important because if we think of where processing happens, many times for those of us who potentially are leveraging cloud platform, you're thinking, yeah, I'm going to run a Lambda, I'm going to run a serverless application. It's going to take that data in, it's going to run a function, it's going to transform it and send it to the particular backend that I need. And that works great. There are some caveats with maybe high amounts of data, large amount of function calls, but you also have to get that data up into a particular area. Now, the way that we've tackled this challenge and this problem is by bringing processing into your data plane. So if we think of how users segment their architecture, they have a full control plane. That's what Calyptia provides. It's got a console, it's got a UI, it's got an API. It even has meta observability, which is how is the pipeline itself performing? How many records are coming in? How many are dropped? How many are stored? How many are retried? And then from a data plane, really keeping that as close to your public and private cloud as possible. So your VPC, your boundaried environment. And by doing that, giving you the ability to push processing down to those places. So you don't have to send data outside of your boundary. It's all happening inside. Now, this is really great for more security focused use cases like, say, redaction or removal of key fields, because you never have to get that data into an at-risk location. So let's talk a little bit about why even tackle processing in the first place, right? Many times we just want to connect our data from A to B, and as we do that, we really want to make sure we don't have blind spots from an observability perspective, maybe no blind spots from a security perspective. So some of the main things that come to mind is logs just inherently don't have a lot of schema or formatting, right? We are dealing with just blobs of text. Someone somewhere said this is how we're going to interpret the data, especially custom applications. For those of you who are potentially on the call that are collecting logs from maybe your developers or from folks who are writing custom logger commands, that can be a bit daunting because a lot of times folks just don't follow a particular format. So one of the reasons we want to process is to say, hey, we want to conform to something, and that will give us some ability to figure out what is happening. Removing sensitive information. So again, as I mentioned, there is that data layer where everything is within your data center. It's processing as close to the data source as possible. And by doing that, if you need to remove sensitive information, remove information that's PII or personally identifiable information, you have that capability to do so within the context of the pipeline. Now, noisy logs are another big one. I think we have gotten very, very lucky with some amazing integrations by backend providers. Yeah, let me just connect X, let me connect Y, let me connect Z. And we're in now this really fun, perplexing challenge where connecting all of these different data sources can be very costly. It's really easy to do so, but you might not necessarily need a ton of that data. You might not necessarily need a ton of those fields. There's many times where you might add 50 fields to a particular message that is just really increasing the total size that is being stored in your backend. So excluding that is also of particular interest here. Last but not least is adding things like context. So within these logs that potentially have little to zero format, how do we make sure that we're able to identify where a threat might originate from, or in the observability side, where something might be malfunctioning? And these are important things like, hey, I want to do host name, I want to do GeoIP, I want to do AWS metadata for region and account number, and I want to do Kubernetes metadata, pod, namespace, all of these various pieces. So these are the reasons that processing become really critical to solving the larger business cases. How do we make sure that everyone is writing in the same format or a format that can be understood? How do we make sure that our business is not at risk or leaking sensitive information? How do we make sure that we're not sending too much data or blowing up the back end with useless and costly information? And then last but not least, how do we debug and find the mean time to resolution much faster? So these are all the questions that processing in a very general broad term can start to answer. So with that, let's go into Calyptia Core. I want to show you what this system looks like. Again, the data plane and control plane. How does processing work from a pipeline perspective, and how can we just enact some very basic pipeline rules that go and perform this? So I'm going to go ahead and switch into my Calyptia Core console here. And within the Calyptia Core console, I'm just going to switch my project here real quick. If I come into the home page, what you'll see is there's a lot of ways you can get started here with deploying this data plane on Kubernetes, on your laptop, on a Linux virtual machine, and then of course some playgrounds to do some of this mending before you actually deploy it. And I'll go ahead and click into this, what's called core instances. And these are things that I've deployed in my infrastructure, my data plane, which is a combination of Amazon, Azure, Google, my laptop, and I have this single view of all of these different data planes. Next, I'll click on this core instance that I provisioned for this one. It's called New Server 3, and you'll see I have a couple of pipelines that are created. Now, what is a pipeline? For Calyptia Core, we think of pipelines in two ways. If you have agents that run at the host level that are collecting logs, that are collecting metrics, that are collecting system information that only exists on that particular endpoint or edge, those are edge devices or agent-based pipelines. And then you have Calyptia Core, which can receive those agent pipelines or other receive that agent information, or receive information from firewalls. They can go out and reach out to internet-based sources. They can reach out to cloud-based sources and retrieve that data. So you have a good pull and push, right? If we go back to the architecture diagram here, you have this data plane with scalable and Kubernetes pipelines where they can pull data from SaaS applications, infrastructure clients, or receive that data from the cloud platforms, infrastructures, and clients. So what I'm going to do is a very simple pipeline to show what this all looks like, and we'll go ahead and create a pipeline just called mock data to standard output. You can name the pipeline however you want. I just find that's most helpful to myself. And within this pipeline builder, we can now define some sources. So if I click plus, I can have sources that are from agents. So of course, as the creators of FluentBit and FluentD, yes, here you go. But you can also receive data from others. So Telegraph, Splunk Universal Forwarder, HEC, Elasticsearch HTTP, which is Beats, Logstash. We support many open standards and open protocols, so things like Prometheus or OpenTelemetry, logs, metrics, traces. Kafka, which also goes to Confluent Cloud. Mock data, which is the one that we're going to be using. If you want to do things like inventory data or run a command, you have that available too with something like bash command. Network-based sources, so HTTP, syslog, TCP, and then of course your cloud-based and SaaS-based collection type inputs. So let's just go ahead and click on mock data. We'll go ahead and just keep everything as is. This generates just a very basic field and does that at the rate of 1 per second. And now you'll notice I have this little box that has appeared next to this source. Now, before we jump into that, we'll just finish this pipeline off so we can see what this looks like. And I will send this to standard output. Go ahead and click save there. And we have another box, which again, I'll go into some details on, and we'll go ahead and click save and deploy. Perfect. So we have at the control plane level created a pipeline, and at the data plane level, we are now going and saying, oh, there's a new pipeline that I need to create. It's a pure outbound connection, again, from the data plane to the control plane, and it is going to go enact that pipeline. Now, the nice thing is if you have an agent-based or network-based specific input, we'll auto load balance that for you. So things like auto healing, if I accidentally kill the pipeline, it'll try to restart. All of these things we try to maintain and take care of, from a pipeline perspective. So I'm going to go ahead into my EC2, and this is my data plane. It's all just running on a single VM. And on this single VM, I'm going to go ahead and get that pipeline. Now, if you're familiar with Kubernetes, you might see me writing this command kubectl get pods. The orchestration that we leverage, even for a virtual machine, is all Kubernetes and cloud native based. And you'll see here is my mock data to standard out. So what we're going to do is go ahead and run that command to see the standard output that is being written to that particular pipeline. And every second or so, you're seeing a new message dummy. So very simple, very easy. We've created a pipeline. There's absolutely no processing yet. So let's go and enact that really quick. So let's go back here and go into the mock data to standard out. And now we're going to go click edit. And as we click edit, now we're going to play around with these processing rules. So processing rules at the most basic level of processing, we're going to think of things like enrichment. And you might ask the question, hey, why do we have two sets of processing rules here? And we'll get to that answer here in just a little bit. But let's go and do something super simple. I will use this left-hand side, which will be edit processing rules. And what you see now is our processing rules interface. Now, as the kind of original folks who have been working on FluentBit and FluentD, one of the challenges that we consistently saw was many times you have to do command line to see, hey, how does this actually transform? And it is absolutely a process, but it can be a slow and non-desirable process, right? We want to speed that up, make things as fast as possible, so we can kind of develop within this view. And we'll get into templates here in a little bit, but what I'll first start with is adding a new action. Now, one of the benefits here with Calyptia Core is that we include a number of these out of the box. So these are all processing rules that we have taken and embedded as part of Calyptia Core, and you get to fill in a few forms to do that. And let's see an example in action here. Let's do something like add set value. So we will say hello, and we'll do world. We'll add a comment so we know what we're doing. Click apply. And again, if we think of how we would have to do this with FluentBit FluentD, we would create the rule, we would deploy it, and then we would watch to see how everything looks. Now, the nice thing I can do here is I can just see from a very quick glance what this looks like by testing out this particular action. So here I can see, perfect, I now have hello world, and I still have my 10 events, but I'm also increasing the data size of a particular event by, say, 94%, or in totality of this sample. And this is great if you have particular logs that you want to try out, see what it's going to look like after it runs through a particular process. And once we feel fairly comfortable with this, we can go ahead and apply this, save and deploy. And if we go back to our data plane here, we'll see that the data plane is going to take this particular pipeline and say, hey, I have an update. I'm going to stop this one. And we're going to go ahead and get the latest one, the one that started 5 seconds ago. Go ahead and copy that. Run the same command that we were running before. And awesome, we now have hello world appearing as part of each of our messages. Something very simple, right? If we again think of flimpit flinty, hey, we could do a record modifier, we could do this. What's the need for a very large scale processing pipeline like this? This is the most basic use case. So now let's start to get a bit more advanced. So we'll go back to our pipeline over here, and we'll go to mock data standard out. I'll go ahead and click edit. And now what we're going to do is start to play around with this right-hand side. So if you remember before, we edited the left-hand side, and processing rules come in pairs. You have one for the source and then one for the end destination. And the reason that you might have one for the particular end destination is, let's add another standard output here. And it is going to be very hard to distinguish which one comes from standard out through this particular output and which one comes through standard out through this particular output. So what we'll do is add processing rules to each side to say, hey, we're going to add a key. We're going to add output 1. See what it looks like. Perfect. Save that. Come over here. Add another one too. And then we'll say output standard 2. Check it real quick. Perfect. Save and deploy. And now if we come back to the data plane, looks like it's picked up the latest. We'll go see which one has been deployed. Oh, let's go ahead and do a -F. And you're going to see there's going to be one coming from 1, and there's going to be one coming from 2. So very easily now we're able to distinguish which output it comes from. Again, we're doing some enrichment, but if we start to think of other places where we can do processing, all the same processing capabilities of dropping particular pieces of data or adding particular pieces of data, we can, for example, which we'll talk about later in the webinar, drop 50% of data that goes to a particular backend while leaving 100% to another one. So now we have data flowing. It's there, and it's giving us a bit of, hey, I'm coming from 1 or I'm coming from 2. Well, hello and world are applied to both of them. Okay. So now let's go ahead and talk a little bit more of some of the other processing that we have at our disposal. And start to talk about some more base processing for removal. So if we come back to the same pipeline that we've been working with, what we're going to do is add a bunch of fields here. For example, we'll say, hello world. We'll say to world. And we'll add another field of hi. So this is the new mock data that we're going to leverage. And we can, of course, test this out as well. So write JSON. We can switch our processing from just taking a plain text log, switch it to a JSON-based log. Paste that in, see how it looks. And we can say, you know what? We don't really want that message anymore. We're going to go and look to remove that. So for example, let's go here and we're going to block a key. So we can go block a key. We can say message. And if we run that, perfect. Now we're just keeping hello to, hello world, and hi. So we can apply this. And now if we go and deploy that in our data plane, this will go and restart, and we'll no longer see that particular field show up anymore. And you can see, hey, we don't have that message field anymore. We've blocked that key entirely. And I see a good question. What happens if one of the outputs is slow, like sending data over HTTP? And what impact does slow output have on fast output? This is a common use case that we see is I might have data that needs to go to multiple places. I want to see how much data is going to each place. And some of the more advanced things that we can do within Calyptia Core is nest pipelines. So say, for example, you want to take that data, send it to two places. We can absolutely do that. It'll have a same flush rate between the whole entire pipeline. But if you want to slow things down for a particular endpoint, send data maybe every 60 seconds or so, you can actually nest pipelines. So have a pipeline that points to another pipeline. That other pipeline has more settings, more processing, more slowdown, while the other pipeline or the other output is going as fast as possible. You get metrics about each of those pipelines. They can be architected in many, many different ways for each of those. Okay, let's talk a little bit about some of the other type of modifications that we can do with advanced processing. We'll come back here and let's talk a little bit about advanced processing, which is honestly some of the more fun stuff in processing, right? Our logs generally don't look as simple as line 1, line 2 to 10. So let's go into another project I have called Processing Rule Webinar. And we're going to come over here and we're going to launch Playground. And what I have and what I'll be sharing here after the webinar are some processing rule templates. So these templates essentially are taking the input that you have on the left-hand side, the actions that you've gone and created, and allow you to export them into a JSON file that you can then later import or save, update, and share across the team. So say, for example, you've got this amazing processing rule template that does all sorts of cool stuff around OpenTelemetry schema. Fantastic. You can export it, you can share it in GitHub, and others can start to leverage that too. And they can check based off the input that you've provided that it's doing what it's supposed to. So let's go in and start with some of the more fun ones within advanced processing. So I'll click this block 200. And what you see here is I have a bunch of raw logs. These are Apache HTTP server logs. And I have about 450 events, and I have this block records action. Now, block records as a processing rule is one that's really, really useful. And the way that it's used is you can tell Calyptia Core, hey, if you receive a pattern that matches the following, I just don't even want to see that record. I don't want to see that record at all. And it will get rid of that record completely. Now, the other side is if, for example, you have multiple outputs, you can block records for specific outputs and leave them on for others. So say for a particular, you have 3 outputs. One output could block 100% of the 200 error codes. The second one could say, I'm going to accept only 404s, and the third could say, I accept only 500s. Why you would want to do it, I don't know, but you have that capability to do that. Now, if we run this, we can easily see that, from the 450 events, we are cutting this down all the way down to 49. And as we're cutting down from 450 to 49, that's a fairly significant data volume reduction. So you can paste a decent amount of data in here. I think we have a 256 kilobyte limit, but that allows you to actually get some good logs going to understand what might be happening for a particular event. Now, the other part within when we think of the Fluent ecosystem and the Calyptia ecosystem is also parsing. Now, parsing is taking this unstructured log and really giving some fields that make sense here. So what we could also do from a processing rule or action standpoint is adding this parse. Now, from a parse side, we can choose the source key, which again is log, and we'll choose where this is going to end up, and then we can add a regex. Now, the fun thing is because this is Fluent, we can just take the exact Fluent parsing rule that we already have. Just copy that. This is the parser's conf that comes out of the box with Fluent. You can, of course, parse as you're ingesting as part of the input, but we might want to just do that after the fact, and we might want to do something custom. We'll say parse Apache HTTP, apply that, and let's run to see what this looks like. Okay, so we lost a bit of reduction, but if we expand out one of these fields, we're going to see what this parse looks like. Right now we have a code, we have a user, we have a refer, host, method, agent, time, size, path. And the cool thing about these processing rules is we can try and see what each of these look like. So, hey, what if I actually didn't block any of these? Okay, so it looks like I'd still increase by a significant portion. So we will go ahead and remove that. Maybe I don't want to do the parsing, for example. And what does that look like? Now it looks better with it, so we'll turn that back on. And now we can take this structure that is already placed into this new record and keep adding on top of that. So for example, one thing we could do now is to flatten that subrecord. So let's take that parsed value, and we are going to take all of the fields. We're not going to prepend with anything right now, but if we want to, we can. We won't keep the original key or submap, and then we can run this. So now at the top level, we have code. We have the same log that we had before, and then all of the additional fields as part of the top level log message. So if it gets indexed by a particular backend, it's going to have that data so that we can search on these particular fields. Now, we don't really want that original log field, right? That's not something that's useful to us. So why don't we just go ahead and block that entirely, and we'll just block the log key, remove log. I think there is also, there's a lot of these rules out of the box. We can, we can even do not just the block, but if you want to delete something very, very specifically, you have that delete there as well. So we're going to go run that. And now, cool, with the parsing, we're almost back to that same 89% that we were before. And we have a lot more structure as well. So say, for example, we want to now block on another value. We can take that processing rule, drag it to the bottom, edit what this is, and maybe say, let's just block all the 404s now. Because now it has structure, we can leverage that on the new side. So, okay, great. Now we've blocked all the 404s. We're just left with 500 and 301s. So you can easily see how you can start to leverage these type of processing rules to do some fairly complex transformations. You can try things out, and as you're trying these out, be informed of what that decision might entail from a size perspective, a cost perspective, and a format perspective before you deploy it out into the infrastructure. Okay, I see some questions here. Let me make sure I can answer those. So sometimes, I think I saw many times in Fluentbit when I use processing rules is that added fields are not always added in the same position. For example, I'm using a Lua parser to add the tag name as a field, and when you review the logs, you can find the new field appended to the start, maybe the middle, other. Yeah, this is this is an interesting one, and actually what you'll see probably throughout my demos is sometimes these things will somewhat rearrange themselves. Within the JSON side, we typically rely on the backend to perform the full indexing, and so the order of the actual field is not something that we're actively trying to arrange into a certain position. It'd be great to understand if there's something there that is malfunctioning if it's not arranged. But most backends that we've seen are fairly okay with, as long as the keys events are in that particular position. Okay, so let's go into some other processing rule templates. Let me go, switch back into the playground. We have some more that I think are going to be fun. Let's look at one of my favorites, which is really large structured events like win-log beat. So for folks who potentially have leveraged Elastic before, these are massively large records that come from a different agent, something like win-log beat. And as part of this, we might want to do quite a few different types of advanced processing. So right now, the processing I'm doing is taking the metadata field and flattening that into the top level record. So taking the metadata that shows up from the beat and then making sure that it comes into a top level. Now, other things I might want to do are redact, right? So we talked about redacting particular things within a particular file. So if we look at, say, the output here, maybe we want to redact, let's look at a top level event here. Let's say we want to redact this entire message field. Is it something that we're going to probably do in production? Maybe not 100%, but let's add a regex for what we want to redact. And we'll choose star as being the redacting key. Add a comment so we know what it is. And you can see here, now we've redacted the entire thing. So that whole field is a bunch of stars. Now, as part of processing, many times, these larger JSON arrays or nested fields, or just going and trying to redact a top level field is not going to be enough. We might want to select a particular field that is 2 or 3 layers down. So say, for example, with winlog, if we want to potentially look at getting this param1, right? How do we go and redact a nested field without having to bring it up, copy it, delete it, and then bring it back? So the way we can do that is by using this thing called record accessor. Now, record accessor has one common format. You put a $sign, and that now says, I want to access the internals of a particular field to get that content. So we can say winlog dot event data dot param1, and we'll do the same dot star, run that action. And now we're redacting, instead of the message field, just that param1 field. So we are now taking that very specific thing to go in and redact it before it gets sent to that particular backend. So you have that capability to access nested fields, which is something that comes up quite a bit, right? Where right now we have winlog beat, say, for example, I open up something like CloudTrail. This is another one that's very voluminous. You have a ton of things here, that a bunch of fields, nested fields, arrays, things that you might want to access, and having the ability to not just say, I want to select this particular key, it's I want to select this particular array value, this particular key value from that array is all possible as well. I think was there another question that I saw there? Okay, awesome. Let's go into some more fun samples here. I'm going to go ahead and refresh this real quick. And we'll talk about one of my more favorite samples, which is this CloudFront. So when we think of schemas and all the innovation that's happening within the schema-based environments, it's all about how can we take a common set of parameters and fields and apply them to a very jumbled or non-formatted existent type of log. And so here I have a bunch of CloudFront logs. There's just some spaces in between them. This thing is really raw. There's nothing, right? It's just coming in as a raw text. As Calyptia core accepts a message, it's going to automatically put a log key as part of it. And then what I've done is written a custom Lua. So while we want to feel like, hey, as Calyptia, all these 20 processing rules are what you're going to need out of the box, we're very realistic. We know that there's going to be times where you might want a slight altercation, you might want a slight difference between what is there and what is available. And so we have incorporated what's called custom Lua. So within the subsystems of Calyptia Core, where we run FluentBit, a customized version of FluentBit, we have allowed you to write custom Lua with all the libraries that we include. So things like XML, CSV, regular expressions, hashing, all of that exists. And what I have here is taking in this CloudFront log and adding OTel schema. So open telemetry, folks are familiar with it. It's building schemas for logs, metrics, traces. As a Fluent project in Calyptia, we adhere to it from the input side, output side. It's a really exciting time for the observability space. Now this is pretty massive. So, we're taking this literally zero schema log and then adding a full-on type of attribute on top of it. So taking it from its base of I don't have anything to now here's a whole entire event. Of course, the downside of this is it does increase the amount of data that you're sending per record. But when someone sees an event like this, they might be able to much better diagnose and troubleshoot what is happening or what is going on for one of these things. Now, one thing you might have noticed within the custom Lua, I breezed past it a little bit, is we understand that not everyone is going to know Lua out of the box. And there is a ton of innovation happening within the generative AI space and how folks are leveraging that to write code, write Lua, write FluentBit configurations, write Calyptia core configurations. And so we wanted to make sure that users get to do this too. And the fun thing is, right, when we think of this extreme separation between the control plane and the data plane, it's not like this generative AI touches the data that you have. This is running purely in the control plane. So you use it really to give you samples and guidance, but then when you deploy it, it goes down to the data plane running on your data in the boundary without having to worry, oh, did OpenAI accidentally take my logs? No, you don't have to worry about anything like that. So maybe we can ask it to do something very simple, and you can tell that it is experimental, and this is most likely where demo daemons will erupt, but let's see. Add field A to the log file. And we'll ask it to generate something, and it looks like it can somewhat do that. Let's see what it returns. Okay, it looks like it added something that was null. Maybe we can go and modify that just a bit. Let's move that below, and then let's modify it let's modify it just a bit here. Just say instead of nil, maybe something more meaningful like, I don't know, my name. And there it is. So if I don't know Lua, which I'll be completely honest, I don't know Lua that well, we can leverage tools that the industry is pushing to help us build some of these processing rules. Is it going to be 100% accurate? No, but it gives us guidance. It gives us some ability to understand how to do something, and we can modify it to meet the correct output that we particularly want. Okay, so let me go ahead and close that. We'll refresh that there. Now let's talk very concretely about some of the strategies for data reduction, right? We've talked a little bit about melding, meshing, redacting, taking some of the values, but let's talk very concretely about data reduction here. And to do this, I'm actually just firing logs to a logging service called New Relic, something really fast, easy to spin up. And I'll go ahead and switch back into my other project here. Awesome. Let's go ahead and edit this project. And really, there are three different ways for data reduction, right? We already kind of talked about this ability of editing your processing rules, adding something like block records. that can go in and say, hey, if something contains XYZ, we're going to remove it, right? So we have line 1, 2, 3, 4, 5, 6, 7, 9, 10. And because of that, we reduced 1 out of 10, 10% of those events. So this is where, hey, from a block record side, it's fairly easy, simple to go about doing something like that from a reduction standpoint. But we do have some more complex types of reduction scenarios as well. So if I click into this editing processing rule, you can see that it is doing a deduplication. So it is taking on a 5-second time window this message key and reducing it so it only sends one message key every 5 seconds. So I'm going to go ahead and just turn this off real quick, or I'll just delete this entirely so we can see what this looks like without the deduplication. So we'll even increase the rate a little bit, so 2 a second, and we'll go save and deploy. And as we come into New Relic, maybe let's change the message name as well. Have a little more fun here. Let's change from message dummy to maybe message on our processing rules. Save and deploy that. Then I'll go out there. And if we come into this, let's do a live tail, see what is incoming here. And it'll spin up, and there we go. We have some data starting to flow on our processing rules. And you can see it's coming in right at a decent rate here. So every 2 seconds, and I'm getting a kind of a new record here. And we'll go ahead and just remove this 30 minutes. Maybe let's use something that's a little less if we can. Looks like 30 minutes might be as much as we can get it here. That's okay. Just keep it like that, no problem. And we can keep doing our live tail for incoming rules. Now this is great. I have 10 logs coming in about a second, or in the time period that New Relic is aggregating them. But to be honest, right, this is not providing any more contextual information to me than I need. I only need one of these messages, and I probably only need one every 5 seconds or so. So what we can go back and do is within this pipeline, come back, click edit, and we'll go into the processing rule. We will add a new action. Go ahead and click on deduplicate. For a time window, we'll choose 5 seconds, and we'll do duplicate on that message key. So similar to what we were doing before, we can't really test that here because it's on streaming data. So doing a time window. In the testing out framework, you can actually add time stamps and everything, and it will go and try to deduplicate based off time windows of timestamped logs. But for now, I'm just going to save it and we'll watch it happen live here. So save and deploy. And now what we'll start to see happening is we'll still see the same exact thing on our processing rules, but instead of it coming in at like this 10 per second, it'll go back down, most likely to this about 1 per second or 1 log. So now every 5 seconds, here is a new log incoming. That is just the one message on our processing rules. Just as a quick check, my AirPods did die. Can folks still hear me?
Loud and clear.
Excellent. Perfect. Thank you, folks. And if we go back to the same pipeline, another strategy that's fairly simple as well, besides just deduplication, is sampling. And sampling is exactly what you might think it is. And this would be, let's go random sampling. We choose a time window and we choose a sample, maybe 10% of those specific logs. So say, for example, you're just getting a huge stream of data and you want to send a sample one place and you want to send everything to maybe an S3.
that is absolutely something that you can start to leverage and do within the way that you can build these pipelines. So maybe you'll send it to S3, archive. And let's definitely turn on some gzip and then save that as well. And now we're sending some sample logs up. I have this over here in my source, so I'll delete that. And we'll apply it, say new relic will only get the sampled logs. And all of the logs will hit the archive as well. So those are some of the strategies we have around data duplication, deduplication.